This is my reverse engineering product redesign presentation. The product we were attempting to redesign was our competitor's Piggy flashlight. Our objective was to find out what our customers wanted out of the flashlight and redesign the original flashlight to fit the needs of our targeted customer base. To find out what our customers need out of the product, we did an interview. We came up with 9 questions to ask a few individuals who might fit our target audience. In order to get the most out of our questionnaire, we used open-ended and neutral questions, so the interviewees were more likely to answer honestly and with constructive criticism, so that we know how to best alter the design to be more appealing to our customer base. And this is our interviewer chart. In these interviews, we interviewed a few different people of varying age and gender. There was a variety of answers for the questions we asked, but there were some responses that were consistent between the people we interviewed. Some of the responses, such as "I think it should make more light" and "the crank is just too loud," gave us clarity because they were all saying something similar in their responses. And this is our chart for how we picked the customer needs. After we had interviewed our potential customers, we needed to pick out the most important suggestions that were suggested and identify them as our customer needs that we would need to design for. In this table, we identified the suggestions we were given and based the importance of the suggestions based on how often it was said in the interviews. Things that were suggested a lot, such as the brighter light, which was mentioned 12 times, got a 100% importance, the most important suggestion we used for our customer needs. And these are our needs metrics table. So next we had to figure out how to measure the performance of our flashlight. The metrics being based on the customer needs we identified in the last step. We needed to be able to identify it if our flashlight outperformed the previous design. So we found units to measure the customer needs in. For the light, we ended up using light intensity or lux at 1 and 20 centimeters. For the strength or resistance of the crank, we use the maximum force we need to apply newtons to the crank. In order to compare the two designs, we measured these qualities in the original design and came up with the target our design needed to reach for each variable. The functional models. So this was one of the most important functional models we used to determine how to redesign our better flashlight. This model is an exploded view of the original Piggy flashlight, and this helped us to understand the internals of such a flashlight and how to make it work and how the internals and externals could be redesigned. This is our mind map. The mind map was used to take our most important customer needs into account and connect solutions to that need. This helped to better come up with many solutions that could be used in conjunction to satisfy our customer needs. And this is the action flowchart. The action flowchart was used to map out the actions a user might take to use the flashlight, and we linked functions the flashlight must do when acted upon. By doing this, we were able to identify design opportunities we could use to address the functions that were required of the flashlight to do. This helped us to think about how the flashlight will increase the crank strength. If you squeeze the flashlight crank, the flashlight must resist the force from your hand. So we decided we needed to redesign the flashlight with a lower gear ratio to resist the force from your hand and in turn speed of the generator side in order to increase the brightness of our flashlight. And this is the black box model, and the black box model allowed us to identify the functions for individual parts in our flashlight and identify how energy is transferred in the system, or transformed in the system. This was also very helpful in discovering the need for a lower gear ratio on the generator. We modeled that the magnet and coil converts rotational mechanical energy into electrical energy. In order to increase the brightness of the flashlight, we needed more electricity, so we need more rotational mechanical energy. Faster spinning gears and magnets. Because of this, we needed to increase the force from the hand by adding gears to increase the resistance on the hand and cause the final gear and magnets to spin much faster, thereby producing more electricity and light energy. And this is our final design proposal. This is the final technical drawing of our proposed flashlight. We kept the original pig design, but decided to add rubberized grips, as shown by the shadowed stripes on the drawing. We also lowered the gear ratio inside and added stronger LEDs to produce more light. Another important thing we added that wasn't included in the original design was a USB-C charging port to charge an internal battery. This battery can also be charged through the energy created by the hand crank. In order to improve the noise created by the crank mechanism of the flashlight, we used oil and better quality gear so that the moving parts aren't vibrating as much. We also implemented an insulation inside to dampen any other noise that can't be eliminated. Now, for pricing and manufacturing, we should be able to bring down the cost of the mass-manufactured flashlight down to just $5. The pig flashlight will be sold at most major retailers for around $10 to $15. And the original market price of our competitor's flashlight was $5, but lacked quality in its materials and construction, as well as being unappealing feature-wise for a large section of the market. For our marketing, we're trying to market towards people who work in rough conditions, such as construction and outdoorsy people. This is because our flashlight is designed to be rugged and has increased grip so you don't lose it in precarious situations. We plan to do TV and magazine advertising to particularly camping magazines. This is because a flashlight that will never run out of batteries and is strong enough to survive nature will be very appealing to a camper or possibly a hunter.